Hello, my name is Tony Botting and I'm a simulation specialist at GoEngineer. In this video we'll show a way to calculate the density in air as assumed for environmental conditions in a flow analysis. Let's look in the engineering database at air. You'll find the molecular mass as shown here. It won't show you the density because SolidWorks flow simulation will automatically calculate the appropriate density for the conditions in the flow. Say you are running your CFD analysis of an aircraft at 36,000 feet and you want to determine the ambient conditions at that altitude. You would have consulted the U.S. standard atmosphere as shown here and used the pressure and temperature values for that altitude when you set up the initial and ambient conditions in flow simulation. We look up in the table and find temperature at 216.7 Kelvin and pressure at 22,632 pascals. You can also check to see what the density is at that altitude and see that it's about 0.35 kilograms per meter cubed. Pressure and temperature values would go into the initial and ambient conditions dialog in flow simulation like this. Right-click on the input data icon and choose General Settings. This might be an external flow, so I'll check that. On the navigator on the right, select the Initial and Ambient Conditions item. You'll see thermodynamic parameters where you would enter the pressure and temperature. So I'll enter the 22,632 pascals and the 216.7 degrees Kelvin. To calculate the density of the air under these conditions, you can use the ideal gas equation like this solved for density. Here, P is the pressure in pascals, big M is the molecular mass as listed in SolidWorks flow simulation, with units of kilograms per mole. R is the universal gas constant equal to 8.134 joules per degree Kelvin mole, and T is the temperature in degrees Kelvin. For our case, we get the density equal to 0.364 kilogram per meter cubed. In this video, we showed how you can calculate the density of air for ambient conditions.